This presentation, is going to deal with how the INNOMATH project is going to provide support to gifted students in solving industry problems. Thus, we are to consider the following terms: industry needs, problem-solving competencies of gifted students in mathematics. But before we deal with the INNOMATH itself, I expect that you are expecting an answer to the question. This conference deals with STEAME. So how does it relate to another project, the INNOMATH project, and its outcomes? Before indulging into the answering of this question, let us spend a few moments in the STEAME approach, thus identifying some of its characteristics that allow us to refer to the goal of this presentation. STEAME, science, technology, engineering, art, mathematics, entrepreneurship, is a term that we adopted for quite a long time. Personally, I would prefer the acronym ATESME: art, technology, engineering, science, mathematics, and entrepreneurship, which reflects the development of man in time. This is just the representation. Art is the first artistic creation in caves by the prehistoric man, reflecting his needs for expression of feelings and inner emotions as it is understood in the real world. Upon is really very good represented. Furthermore, art is the application of human creative skills and imagination in a context of virtual reality, communicating messages and meanings. I'm just really started from this point just to show that actually we're going back to the origins of human history if we adopt the STEM approach. Technology, use of tools, invent. I'm just stressing a few verbs that I consider is quite important. Invent, innovate, improve the natural world and adapt it to the environment. And really, Hephaestus was a representative of that. And it just the one that constructed the first robot, Talos. Certainly that's the mythology, but just the ideas there. Engineering, control. This is the meaning. Control, modify, design, create. Move to activities for adapting to the environment, to the needs of the human activity. And Archimedes is really an excellent representation. Science, observe, experiment, discover and describe, organize and understand the environment. Aristotle, with his taxonomy and so on. Mathematics, symbolic language, abstraction, representing reality as well as virtual reality, modeling and extending to other situations. You can see here, I just, if you consider the allegory of the cave, it's just one of the most, the first steps really about virtual reality. Entrepreneurship, that was not really many years ago. Setting up business, taking risks, aiming at profit, producing and promoting goods, engagement in the real world, and providing means for satisfying human needs. Bill Gates is an excellent representative, and just something that he said, if you are business is not on the internet, then your business will be out of business. In reference to the meanings of the acronym, reflecting some of the aspects and indirectly the goals of the STEAME approach, that is connection to the real world, critical thinking and problem solving, collaboration, cooperation, communication, leadership, ethics and responsibility, creativity, innovation, ingenuity, and novel ideas. These goals are also the pillars around which the INNOMATH project was built. To put it in somehow differently, the INNOMATH project aims at analyzing good practices and methods used to support gifted, talented pupils in schools in the area of mathematics, developing guidelines for mathematics meets industry in school, knowledge to innovation through practice and so on. Developing electronic guidebook of methods and tools for teachers, facilitators, developing a course for teachers, facilitators for supporting mathematically gifted students. So the important concepts in the INNOMATH project are developed in the context of supporting mathematically gifted students in school so that they are involved in real-world problems, meeting and cooperating with industry. They have the opportunity to develop enhanced competencies for critical thinking, problem solving, collaboration, communication, cooperation, creativity, invention, innovation, ingenuity, demonstrating novel ideas and ethical and responsible approaches in managing the issues they face. In this effort, the INNOMATH project has produced a range of outputs that support and serve these ideas. Namely, if you want, you can access the website of the project, and certainly by doing that, you are going to have the opportunity to get material for gifted students through the use of this website, an electronic guidebook of methods and tools for teacher facilitators, providing material for good practices and methods used to support gifted talented pupils. And this book has the following parts: definitions and characteristics, the first part. The second, a collection of good practices and methods used to support gifted or talented pupils, and supported by a Google folder with material that is very helpful for the students. And part C, mathematics meets industry in school, knowledge and innovation through practice. It's a guidelines. But in particular, what is important for part C, it provides material for the Mathematics Meets Industry Day design, which really produced quite a lot of interesting outcomes. Furthermore, the INNOMATH project provides for a training course for teachers, facilitators, covering 10 modules, enriched with a set of examples of learning plans for supporting gifted students in a range of mathematical areas. The 10 modules for the teacher's course cover the following units. Module 1, its access and use of INNOMATH project findings, including the midday, I think, model. Model 2, it's about inquiry-based learning. Model 3, it's about discovery-based learning. Model 4, it's about problem-solving methods. And Model 5 is about project-based learning and project methodology. Furthermore, Module 6, it's a presentation, and it's about presentation and communication skills, which are quite important. Module 7, raising the entrepreneurial mind set in school students. 8, it's about cloud computing and cloud education. Module 9 is about the evolution of education and the future schools. Part of that has been already presented by Thomas, and tomorrow we are going to have the opportunity to listen to these things from Gregory. And it's about cooperative learning for teachers and students. As can be immediately seen, the content of these modules reflects to a great degree what we want to stress through the STEM approach. Certainly, in order to provide some illustrations, I would really just say that we have learning plans for quite a number of these ideas, and you are going to have the opportunity to go into the web page of the project to have access to these things. Sorry?
You can click on it if you want to show it.
Oh, no, it's okay. I just want mainly to stress an example, which I believe that just give you the ideas. Certainly, there is an example of a learning plan which has to do for the linear program using the graphical approach. Just here you see a learning plan, and it's just about this topic, and there are quite a number of activities that are really going to help gifted students in order to just achieve what we want them, really to be part of what is their intention to solve problems that are interesting to the industry. So what we really started is just, if you consider the first activity that we want really these students to consider. Okay. This example that I have just chosen to you is just in order to stress something that really is part of what we are facing at this moment, not only at a local level, not only in Cyprus, but I believe not only in the European Union, but all over the world. At this moment, an issue that is quite challenging is really the huge increases in prices for many goods. So really, by just providing an example or a restricted problem to these students, we just prepare them in order to reconsider issues that they are going to face in real world. And just the whole activity starts from just this kind of problem. The farmer is making two types of foods, type A and type B, for his cattle. And it is given that each serving is required to have 75 grams and so on and so on. And the issue is really, if there is a change to this distribution, how much of each type should be used to minimize the cost to the farmer. The whole activity is part of that learning plan that I showed you before, and you can get quite a number of answers and really see the whole thing. Another example that illustrates the whole idea has been chosen from the activities in the Mathematics Meet Industry Day event for the EU-funded project that took place in Andros, Cyprus in July 2021. And in that event, the organizers said that they they asked a number of students to consider two problems that were proposed by the industry. It's not really just ready-made problems. The problem A was provided by V-Ships, which is one of the biggest shipping companies in the world. The problem described a specific case of a tanker vessel trading between Singapore and Brazil that needs to be stocked up with provisions in order to have provisions on board at all times. In this project, the students needed to act on the benefit of the catering provider in an attempt to formulate the most cost-effective provisions replenishment plan by making sure that the agreed rates are met. The vessel have sufficient stock on board at any time during the voyage, and at the same time, they had to maximize the profit for the catering company. Another second problem was given by an architectural company, and it just relates to other issues that we do face. And really, the students were considered mainly the problem A, and they presented their results in a gross in the summer, in the last summer. At the end, the industry representative expressed his excitement for the students' hardware, excellent presentation skills, and the analytical way of presenting their solution. He mentioned that it was a great experience for him to participate in that event and meet such students who did a great job. In addition, He expressed his interest to work with them one day. Conclusion. This presentation attempted to justify that the INNOMATH project reflects some of the basic characteristics of STEAM, that is creativity, innovation, critical thinking, problem solving, relation to the real world, and furthermore, it is a useful tool for supporting gifted students in solving industry problems. I hope that you got a glimpse of what the effort is and exploit these ideas either for enhancing the learning process or for further elaboration on the issues involved. Thank you very much.